Hi, welcome to this video on linear algebra. So today we're going to be going over Gaussian elimination. So there's two things to know about Gaussian elimination. There's two flavors to this. So the first flavor is you have row echelon form. So with row echelon form, when you solve it, you might have this 0 in the left corner, and that's called row echelon form. That's Gaussian elimination. If you solve this augmented matrix and you arrive at this solution, where you have these zeros in this position, and you have these ones in that position, well, that is now considered reduced row echelon form, and that's Gaussian-Jordan elimination. So there might be questions. For instance, let me point out that this one is called a pivot point. If it's in reduced row echelon form, this one is called a pivot point. For this one to be considered a pivot point, and every number below it should be 0. So let's just say that you had a matrix that long. Anything below it should be a 0. And this should also be a 0. Okay. That could still be considered a pivot point. If all these numbers below it are 0 and this isn't, it's still a pivot point. However, it's going to be in row echelon form. So this A prime could actually be a 1, right? And this B prime could be a 2, let's say. Well, this 1 is still a pivot point. However, it's in a row echelon form. In this case here, this 1 is also a pivot point. And because it's in this form where it's 1, 0, 0, 1, it's now in reduced row echelon form. So there might be a problem where it says identify if it's reduced row echelon form or simply row echelon form. And that's how you tell. So let's go ahead and take a look at different problems. Okay, so for number 1, we have this matrix, and like I said, let's look at this 1, and we want to tell if it's in reduced row echelon form or row echelon form, and also let's identify pivot points. So this 1 would be considered a pivot point. Every number below it is 0, and because this number here, this 2 is there, number 1 would be considered row echelon form. Okay. If in problem number 1, that 2, let's say, was at 0, well, now that's in reduced row echelon form. Okay. But it's in row echelon form. All right. So let's look at number 2. Number 2, surprisingly enough, is neither. It's neither reduced row echelon form, neither row echelon or reduced row echelon form. Why? Because, let me just point out something in all the other examples. The row at the bottom are all 0, 0, 0, 0 across, right? But for problem number 2, it's not all 0, 0, 0. It's 0, 0, 1. So it's not in either reduced echelon form. So let's look at problem number 3. Problem number 3, let's look at this 1. Is that a pivot point? No, it's not a pivot point. Why? Because the numbers below it aren't all 0, because that one beneath it blocks it from being a pivot point. So which form is it in? Well, it's neither, because there's no pivot position. So this one is neither row echelon form or reduced row echelon form, because no pivot positions. So that's how you look at those problems. Let's look at a problem where it asks us to use a certain method, such as Gaussian elimination. So this problem tells us to use Gaussian elimination. Now what that means is we want to achieve row echelon form. I'm going to abbreviate row echelon form with RE and reduce row echelon form with reduce row echelon form, like that. But this problem is asking for Gaussian elimination, which is row echelon form, I'm sorry. So let's go ahead and put this into an augmented matrix. Let's put it in the matrix. In my class, there were so many references to the matrix while we were going over these matrices. It got pretty old. So here is our augmented matrix. So all we did was we took these x sub 1 values and we transfer them into a column. For x sub 1, we took these x sub 2s and we transferred it to the x sub 2s and this column. And we took these x sub 3 coefficients and we plugged them in under this x sub 3 column. And we took these constants and we plugged them in into this column. Okay? And we lined them up. Great. Okay, so we're going to apply those elementary row operation here. So let's do R1 plus R2. And when I say, I think I'm going to change the color. Okay, so we're going to do R1 plus R2. And what I mean by R1 and R2, I'm talking about the rows. R1, R2, and R3. So basically what this is saying, R1 plus R2, is you're saying you're going to add this row 1. You're going to add row 1 with row 2. And whatever you get for that, you're going to get a new row 2. Okay, so if you look here, if I do row 1, so that's 2, 2, 2, 0, plus R2, which is negative 2, 5, 2, 1. The sum of that will be a new R2. So let's just compute that. So we have 2 plus minus 2, 2 plus negative 2, which is 0. We have 2 plus 5, which is 7. 2 plus 2, which is 4, and 0 plus 1 is 0, is 1. So that will be our new row 2. So we can write this matrix again. Row 1 doesn't change. Okay, so we have 2, 2, 2, 0. But what changes is row 2. So now we have, I'll write it in blue, our new row 2 would be 0, 7, 4, 1. And row 3 doesn't change because we didn't do any operations to that. Okay. So again, what did we do? We took row 1, we added to row 2, and the sum of it was our new row 2. We did it here, we added them, and we got a new row 2. And then we replaced it with a new matrix, okay? So we have to continue to do that. Let's continue on the next page. Okay, so this is our modified matrix now. So we're going to apply another operation to it. So we're going to apply R1 times -4 plus row 3, which is equal to our new row 3. So why am I multiplying row 1 by -4 and then adding it to row 3? Well, if you can picture this in your head, if I multiply by row 1 by -4, this first term will be -8. And if I multiply it to row 3, and if I add it to row 3, this new row 3 will be a 0, right? So minus a -8 plus an 8 will make this new row, this right here, 0. And that's exactly what we want to do. And this is key. What I'm about to say is key to the entire class. Whenever you are working with these matrices, you need to focus on this one column first. You need to make that 1, 0, 0. So anything that you have to do to make that 1, 0, 0, you need to focus on applying to this one row first. Don't try to make anything else until you have that first row to look like 1, 0, 0. Okay? Because later you're going to want to make your matrices look like this, right? And you might see a row starting to begin to look like this in the beginning, but you're like, no, I can't do that because I need to focus on this one column first. I need to make this first column to look like that. So let's focus on the first column first. And I guarantee if you focus on the first column first to make it look like 1, 0, 0, I guarantee you'll get the right answer every single time. And whenever I help a student out, they always mess that up because it's just not clear that you have to do it that way. So I hope now that it's clear, you won't be stuck on that. Okay, so I apply that. Sometimes I would like to write it down and then erase it, like on my exams. Oops, that's not what I want to do. So sometimes I'll write down the entire row 1 and I'll multiply by -4. So I'll do -8, another -8, another -8, and I'll put a 0. And we're going to add that to row 3. What is that? 8, 1, 4, -1. And then I'll get my new row 3. Okay, so I'll do -8 plus 8, which is 0. -8 plus 1 is -7. -8 plus 4 will be -4. 0 plus -1 will be -1. That's a -1. -1. Okay, so I'm going to write row 1 just how it is I don't know how I'd move that. That was interesting. Row 1 stays the same, so that's 2, 2, 2, 0. Row 2 is the same because we didn't do anything to it. And row 3 is what changes. So now we have 0, -7, -4, -1. And maybe one more thing to point out. Let's see. Oh, right. So one thing to point out is the first row that you're going to be manipulating, whatever, this won't change. Like in the final matrix, if you know what I'm saying. We'll only multiply it by something and then add it to the next, but it's only the latter row is the one that changes. So we added we multiplied -4 to row 1, and then we added it to row 3, but row 3 was the only one that changed, right? So that's one thing to keep in mind. Okay, so now that we have this new matrix, we have this one. Remember what I said, we want to focus on this first row. This first column, and we want to make it look like 1, 0, 0 coming down. So it seems pretty simple as to what I have to do to that first row to make it a 1 for the first number, right? So I don't know, I guess I'll just go down like that. What I'm going to do is I'm going to say row 1, and I'll multiply it by 1/2. And that's going to equal row 1, a new row 1, right? Because that's the only one I'm changing. So if I multiply row 1 by 1/2, that's going to get me 1, 1, 1, 0. And I didn't do anything to the other rows, so they're going to stay the same. 0, -7, -4, -1. Okay, so now I'm sure you can see what I could do next, but let's not get ahead of ourselves. Okay, so I now have this new matrix here. Okay. So what am I going to do now? What I could do now is I could add row 2 plus row 3 and make a new row 3. So if I apply that operation, my new matrix will be 1, 1, 1, 0, 0, 7, 4, 1, 0, 0, 0, 0. Great. So what were we trying to do? Oh, that's right. We were using Gaussian elimination, which we wanted reduced echelon form, and reduced echelon form looked like, oh, was I saying? I'm sorry, we wanted row echelon form. Too many R's. So we wanted row echelon form. I'm so sorry. With row echelon form, we just needed, let's get rid of these numbers. We just needed any number here in these positions, and we needed a 0 there. So it could be, A prime could be anything, B prime could be anything, but we do need the 0 here, and D prime could be anything to get row echelon form, which is Gaussian elimination, right? So let's go back and see if we have row echelon form. So this is our matrix, and it looks like we have row echelon form. Let's see, we have a 1 pivot point, and we have everything below it 0. So let's just think back. This was our A prime, B prime, and d prime. Yep, it looks like we have row echelon form. Great. So what do we do with that now? Well, let's take that to the next page. We had 1, 1, 1, 0, 0, 7, 4, 1, 0, 0, 0. And I do that dotted line because I do want to separate my constants so I know which are my constants and which are my variables. So this is x2, x3, and my constants. So now that it's in row echelon form, boom, great, we did what we were supposed to do. We want to now convert this into systems of equations, okay? So I have x1 plus x2 plus x3, and it's equal to 0. So all I did was I took this x1, so I took this coefficient, 1 times x1, this coefficient 1 times x2, x3, which is 1 times x3, and equal to 0, which is that constant. Okay, so there's one equation, and my next equation will look like, it'll look like there's no x sub 1 coefficients, but there is for x sub 2. So I'll say 7x2 plus 4x3 equal to 1. And if you notice, there's no, that's actually a 0. It's not a 6. 0. So there's no terms or variables that can go for that last one. So that tells me I'm going to have to make a substitution. So x3, let's say, is equal to t. Because there's no way that we can solve for 3 variables if we only have 2 equations. We would need 3 equations. So that's why we make this parametric substitution, okay? So let's go ahead and solve for x2. So here's our one equation, one solution already. x3 is equal to t. So x2, if we make the substitution here, x2 will equal 1 minus 4t over 7. So all I did was substitute that t in for x3. Or I can say 1 over 7 minus 4 over 7t. Okay? So there's my x2 solution. Now let's solve for x1, which will end up being negative 1 over 7 plus 3 over 7t. So those were all my solutions. So I don't know how the professor will want it, but you could either write it like this, or you can write it like this. Equals. So I will first write my t's. So let's say 3/7 for x1, and for x2 I have negative 4/7, and for x3 I have 1, and I'll write it down, then I'll describe it. x1 has a negative 1 over 7, x2 has a 1/7, and x3 has 0. Okay, so what did I do? So, like I said, you could either write it as these solutions, which I think is okay, or you can write it in these matrices. You can write it as 3 over 7 times t, minus 4/7 times t, 1t, and that's basically pulling out these t variables, and then you can add the constants. So for x sub 1, you have negative 1/7. For x sub 2, you have 1/7. And for x sub 3, you just have the 1t, but there is no other constant. So all it is x sub 3 is equal to t. Okay? So that's basically one way to solve it if you were asked to do a Gaussian, elimination. I guess you may see, before I go to that, the main thing that I wanted to go over again is this. Remember, in order to solve any of these augmented matrices, our main goal is to get this row to be 1, 0, 0. Okay? And we did that by only focusing on making one column 1, 0, 0. Okay, so let's see, we went from 2, 0, 0, and then we multiplied by that half, and we got 1, 0, 0. If we wanted to, we can do Gaussian-Jordan, which is reduced row echelon form. We can make this 1, 0, 0, 0, 1, 0, 0, 0, 1, and we'll get to how to do that when it asks us to. But I just wanted to point out that we want to focus on one column at a time, okay? So focus on this first column first, and then focus on the next column, and then the next column. Okay, so that's something I want to stress heavily on. So let's talk about this one last thing. Trivial. This might come up, is trivial solutions. So trivial solutions is simply when all the variables are equal to 0. And it might come up, so it's trivial because all the variables are equal to 0. That's basically all I wanted to say. So next we'll talk about more operations that we could do to matrices. So thanks for listening.